Good afternoon, everyone. In our last lecture, we started the thrilling journey of rotational dynamics. That is, we were studying the numerical problems of the chapter given in your textbook. So I think we have completed up to number 15. I hope you understand the method and understand the steps how we can solve easily the given problems by writing the data first and using the formula. So one thing most important you must remember while solving the problem, if you have completed your theoretical study, then only you can solve the problems. Otherwise it is very hard to remember the formulas and put the values in the formula. Which formula we have to use, we can understand only when we have completed the total theoretical study. So I request you all, first you complete the theoretical study and then you try to solve the problems, whether for board examination or also for the competitive, that is MCQ type of examination. So let's see the 16th number problem there again. So during the stunt, a cyclist considered to be a particle is undertaking horizontal circle inside a cylindrical well of radius. The radius of that well is given, that is small r, it is equal to 6.05 meter. The radius of the well is given. If the necessary frictional coefficient of friction is given, it is equal to 0.5. It is unitless quantity. How much minimum speed should the stunt artist maintain? Its minimum speed of revolution inside the cylindrical well we have to find out. Mass of the artist is given, that is small m is equal to 50 kg. And also we have to find out if he increases the speed by 20%, there is no any effect of increasing speed on the friction force. So 20%, how much will the force of friction be? And force of friction also we have to find out. Fs equal to question mark. Fs can be easily calculated. See here what is given first. It is a cylindrical well like this. So this is the cylindrical well, and at any point inside the well that artist is performing circular motion. Suppose this is the circle of that artist. So at this position it experiences three forces. First is force of friction in upward direction, second is force mg in downward direction, and here it is normal reaction which is provided by the that wall of the well. So this is normal reaction provides necessary centripetal force, we know, and Fs equal to mg, and after solving that we have the relation, that is here you can write, we complete again, capital N is equal to m v square upon r, and Fs is equal to mg, but is Fs equal to mu into n. So mg is equal to mu into here m into v square upon r. So m get cancelled, and finally v square is equal to rg by mu, and finally v can be written as square root of rg by mu. If you put the values here, so v equal to square root of this r is given 6.05, g we considered as 10, and this mu is given 0.5. Once again, this 0.5 can be considered as 1 by 2. So v can be written as, it is 6.05 into 2, or you can write this as 60.5 into 2. 0.5 is 1 by 2. So take 2 numerator side. So v can be written as, this is 2 into 5, 2 5s are 10. It is 0, 2 0, 0 plus 1 1, and this is 12. So it is 121. So finally velocity can be written as 11 meter per second. So this is the answer for the question 11 meters per second. And there is no any change with increase in speed on force of friction. It remains constant. So force of friction is Fs is equal to, it is mg. So force of friction equal to m is 50 and g is 10. So Fs is equal to 500 Newton. So this is force of friction between the cyclist or artist and the wall of the well. So this was the 16 number problem. Somewhat tough and conceptual problem is there, 17 number. Read the problem carefully and then solve it. So see here what is given in 17 number, problem number 17. So it is a pendulum consisting of a massless string of length 20 centimeter. There is a simple, actually conical pendulum. The length of the string is given, and then mass is also given. So write the given data there first. What are given quantities? Number 17. A pendulum consisting of a massless string of length. So here L equal to 20 centimeter equal to 2 into 10 to the power of minus 1 meter. Conversion from centimeter to meter. Next one is, and a tiny bob of mass. Mass of the bob is given. It is 100 gram. It is equal to 10 to the power of 2 into 10 to the power of minus 3 kilogram. Means it is 10 to the power of minus 1 kilogram. Mass is given. Gram, it is 1 gram equal to 10 to the power of minus 3 kilogram. So it is 10 to the power of minus 1 kg. Next one is set up as conical pendulum if the bob now performs 75 rpm. The frequency of bob of revolution of that bob is given 75 rpm equal to, it is 75 by 60 rps. So n can be written as, we can cut this number by 15, 15 5s are 75 and 15 4s are 60. It is rps. So this is the frequency of revolution of the pendulum. Find out what we have to calculate. First, kinetic energy. Number 1, kinetic energy we have to find out. Next, an increase in gravitational potential energy. Second part is potential energy, that is delta PE, we have to find out. See there carefully the problem is. So here first we must draw a small diagram to understand this problem. So it is a pendulum first, simple pendulum. It is displaced to one side like this and pushed in horizontal direction. It performs like this, the pendulum. So here it is displaced position, and this one is the height as compared to its ground position, up to which potential energy get changed. Here potential energy is equal to 0 and here potential energy equal to mgh. That we have to find out. Again one thing, here is angle theta, this is L, this is R, suppose this is X. So in this figure first we will find out the angle and some physical quantities. What is sin theta in this figure, or cos theta, sin theta? So first of all, sin theta. Sin theta equal to R by opposite side or length, that is hypotenuse. Therefore small r can be written as L into sin of theta. Similarly, what is cos theta? Cos theta equal to adjacent side, that is x by L. Therefore, x equal to L into cos of theta. So what will H? Therefore, H equal to L minus x equal to L minus L into cos of theta. So finally, H can be written as it is L into 1 minus cos of theta. So these are the required formulas to obtain the desired answer. So first of all, we must calculate theta and cos of theta. So see here carefully, we have the relation for angular frequency, that frequency of revolution equal to, we have this omega equal to square root of, it was G by L cos of theta. So this was omega. So squaring this, omega square equal to G by L cos of theta. So you can write for cos of theta equal to G divided by 2 pi n square equal to G by 4 pi square n square. Again, one thing must be here. What is value of pi square? Pi square is given 10 and G is also 10. So we can find out cos of theta is equal to G is 10, 4 into pi square is 10. What is n? N is given here 5 by 4. So it is 25 by 16. So after solving this, we get cos of theta equal to cos of theta. See here carefully. Is 10 get cancelled. 25 into 4, it is 16 goes to numerator side, and 25 into 4, it is 100. So finally, it is cos of theta equal to there is again L, I think, there into small L. There is L, there is 2 into 10 to power of minus 1. Here it is 2 into 10 to power of minus 1 again. So here we can write 2 into 10 to power of minus 1. So here we get 16 by here 2 into 10. So finally, this cos of theta equal to 16 by 2 is 8, it is 0.8. So this is the value of cos of theta, and therefore theta can be found out as theta equal to cos inverse of 0.8. Using the logarithmic table, we can find out the value of that cosine of 0.8, and that cosine of 0.8 is 36 degree 52 minute. So theta equal to 36 degree and 52 minute. So this is the value of theta. Now we have to find out kinetic energy. For kinetic energy, we require velocity. So velocity equal to, using this relation again, we can find out velocity. So this is omega equal to, using the same relation we can find out velocity. Now linear velocity, omega square equal to G by L into cos of theta equal to, this is V square by R square. So here it is, we have to find out V square. So therefore V square equal to R square into G divided by L into cos of theta. Put the values here. So V square equal to, what is R? R is L into sin of theta. First we can find the value of R also using L and sin theta. So here we get L square into sin square of theta into G divided by this L into cos of theta. So you can write V square equal to 1 L get cancel, here L into sin square of theta into small g divided by cos of theta. So V square equal to, we have this L. What is the value of L? L is 2 into 10 to the power of -1. Here sin theta, sine of 36 degree and 52 minute. If you use the natural sine table and sine of 36 degree 52 minute, we can find the value equal to 0.6. So it is 0.6, it's close to 0.6, actually it is 0.5999 into G is again 10 divided by cos of theta is 0.8. If we solve this, so V square equal to this 2 into 0.68 square, it is 36 into 10 to the power of -2. This 10 and 10 to the power of -1 get cancelled. Here we can write 8 into 10 to the power of -1. So this 2 into 2, that is, we can cancel this 8 using 2 as 4, 4 9s. So finally we get V square equal to 9 into this 10 to the power of, see carefully, 10 to the power of, it is -1. This -1, this -2. So finally V can be written as V equal to, so just keep this as it is V square. So we have to find out kinetic energy. So kinetic energy equal to 1 by 2 m into V square. So what is m? M is given 10 to the power of -2. So this is 1 by 2. M is 10 to the power of -1. And here it is 9 into 10 to the power of -1. So finally we get 4.5 into 10 to the power of -2, means kinetic energy equal to 0.05045 joule. So this is the actual answer. There is small variation in the answer given in your book and this one. You can again calculate carefully, and if you find the answer given book is correct, you keep the same answer. If I am making some mistakes, suggest me. Okay. So kinetic energy equal to 0.045 joule. Last, it is change in potential energy we have to find out. See here carefully. Initially the object, that pendulum is at this position. When we displace this to this position, its height increases by h. So here potential energy is 0. Here potential energy is mgh. So change in potential energy. Second part. Delta potential energy equal to mgh minus 0. So put the values here. So delta potential energy, it is equal to m. What is m? M is 10 to the power of -1. What is g? 10. What is h? See here carefully. H equal to L into 1 minus cos of theta. L into 1 minus cos of theta. Here it is h. So put the values again. So delta potential energy equal to 10 into 10 to the power of -1 get cancelled. Here is L. L is 2 into 10 to the power of -1. Then 1 minus 0.8. Cos of theta is 0.8. So finally we get 2 into 10 to the power of -1. here 0.2, and last it is 2 into 2 4, 0.4 into 10 to the power of minus 1. So finally it is 0.04 joule. So this is the answer for change in potential energy. This is the answer for change in kinetic energy. So, and finally there was one value, that is cos of theta. Theta must be calculated here. So this is the total solution to the problem, which is somewhat twisted in your syllabus. So last one, regarding the circular motion. A motorcyclist as a particle is undergoing. See here, carefully read the problem and try to write the given values. So a motorcyclist is undergoing vertical circles inside a sphere of death. Sphere of death is given, and inside that sphere of death a person, that is a motorcyclist, is undergoing vertical circles between two positions, that is topmost position and bottom position. What are the given quantities? See here carefully. The speed of the motorcyclist varies between see here a motorcyclist is given. So this is a circular motion. This is suppose point B, this is point A, topmost point, and this is bottom point, and it is performing like this inside the sphere of death. The speed of motorcyclist varies between 6 meter per second and 10 meter per second. We know at point A it is lower speed, and at point B it is highest speed. So VA is given, it is 6 meter per second. VB is given, it is 10 meter per second. What do we have to find? Calculate the diameter of the sphere. Is R equal to question mark, diameter equal to question mark. This is diameter. Diameter we have to find out. And next, how much minimum values are possible for these two speeds? How much minimum values? त्याच्या दोन किमती आपल्याला काढायच्या. VA equal to question mark and VB equal to possible values त्याच्या between. So see here, between 2 points we have to find out the values again. What are the possible values? How much minimum values are possible for these two speeds? So we have, it is solution. VB square, we know lower speed VB square minus VA square equal to 4RG. So you can find VB square, it is 100 minus 36 equal to 4RG. So finally it is 64 equal to 4RG, and finally you can write this as 2 into 2RG. So 2R equal to 32 by G, means it is 32 by 10 equal to 3.2 meter. 2R equal to D. Therefore diameter equal to 3.2 meter. So these are the actual values, value of diameter. Then minimum and maximum value. V minimum is equal to square root of RG. Put the value here. V equal to square root of R is 1.6 into G is 10. So V becomes it is 16 equal to 4 meter per second. That is V1. And V2 highest speed, it is equal to 5 Rg. So V2 can be written as 5 into R is 1.6, G is 10. So V2 equal to is 5 into 60, means finally V2 equal to 4 into root 5 meter per second. So these are the values for the velocities at different points. So up to this 18 numbers problem, we have completed the problems given in your book as far as the circular motion is concerned. So next there are few problems 19, 20, 21, 22. These are regarding the rotational motion of the object that we will find we will study in next lecture.